Hi there. In this video, we are going to talk about the graphical analysis of the motion. So let's begin. In order to draw a relation between the position and time, what I'm going to do, I'm going to consider a graph where you can see the x-axis is my time, which is in hour, and my y-axis is the position of the body, which is in kilometer. Now what I'm going to do, I'm going to consider a body moving with a uniform velocity. So I will consider a graph which is basically a straight line. So this line represents the uniform velocity motion. Now what we need to do, we need to find the velocity of the body. So let's suppose that this is the position of the body at time t1 and the position is x1. In the same way, I'm going to consider another point, which is this point. Let the time is t2 and the position of the body is x2. In order to find the velocity, what we need to do, we need to find the slope of this line, because slope is basically equal to the average velocity, or we can say the velocity of the body. So in order to find the slope, we need to get a right triangle. So I'm going to consider a point over here, and then I'm going to connect all these points respectively, and if I do that, I will get a right triangle. Now since I have a right triangle, it's easy for me to find the slope, and we know that slope is basically rise over run. So we need to find the vertical change in position, which is from x1 to x2. So we'll write change in position delta x is equal to x2 minus x1, and at the same time we'll find the change in time, which is my run. So we will write delta t is equal to t2 minus t1. So as you can see, I have my two sides of the triangle. That's what I need to find the slope of this triangle. So let's find delta x. So we know that delta x is equal to x2 minus x1, and we can see that x1 is 50 and x2 is 100. So let's substitute that value, and if we do that, we will write delta x is equal to 100 minus 50, and 100 minus 50 is 50. So change in position is basically 50 kilometer. Now at the same time, we will find the change in time, which is delta t is equal to t2 minus t1, and as we can see, t1 is 1 hour and t2 is 2 hours. So we will write delta t is equal to 2 minus 1, and my delta t is equal to 1, because 2 minus 1 is 1 hour. Now let's find the slope, because if we know the slope, that is basically equal to the average velocity or velocity. So we'll write slope is equal to delta x over delta t, and my delta x is 50 and my delta t is 1 hour. So I will write 50 kilometer over 1 hour, and 50 over 1 is 50. So my slope is basically 50 kilometer per hour, which is basically the average speed, or the speed, or I should say velocity of the body. And this is basically an example of position versus time graph for uniform velocity.